Well, happy Monday. What we are going to be doing today is we are going to be diving straight into word problems. We're going to get straight into that practice, and we're going to be going through the main word problem strategies. So, for the purpose of today, for the first set of questions, I'm going to give you 2.5 minutes, but I'm going to increase that to 3.5 minutes once we get to a more complicated set of questions. So, with that said, let's just kind of introduce ourselves if we're new to these word problem classes. So there are 3 steps to word problem success. So with that said, the first step is what do you want? And you guys typically say is RTQ or read the question. Now, my question to y'all before we get started is why to you, for those of you who have been using the strategy, why is it useful or helpful to you to read the question first? So I don't want to say it. I've said this a million times. Why do you think that it's important to read the question sentence first? Duarte says it saves time. It does, but how? Why? To know what you need to do. Right on, Nakia. Like that, I will know I'm really looking. So you know what you're really looking for. So you know what they want. So you know what you're looking for. To know what I want. To keep you focused. So you understand what to do. To help know the way to go about the question. It's quicker to understand first what you're looking for. Look at what everybody's responses are. Everybody's talking about staying focused, saving time, and not freaking out. And that's true. So if you're here for the first time, if this is your first class, you're going to get a little shell shocked. We're going to dive on into it, but try this out. The first thing you do when I show you this question is not starting from the very beginning saying, Coach Anderson had 17 apples. No, go straight to the question sentence and see what it is the question wants you to find. And see if that doesn't help you read through that beginning information a little more smoothly next time once you know what you're looking for. So try that out. First step, read the question sentence and see what happens from there. And then we'll reconvene, we'll take over, and we'll keep it up. So with that said, everybody, does that make sense? The first thing we want to do again, read the question. Good. Good. We're going to have a fun day, guys. We're going to have a fun day, my party people. So let me get this timer up. There it is. And I'm getting my face out of the way. So once that timer that you see right there at the bottom middle, once that says time's up again, that is when you will share your answers, not any time before. Here we go, my party people. Let's have fun. 3, 2, 1. Let's go. Again, take your time. Read the question, then the information. And we're looking at our final two, 1, and time. Go ahead, plug in your answers. Let's see what we have. Let's see what we have. Go ahead. All right, so a lot of folks here plugging in answers. I see some D's, some C's, a lot of D's and C's. Okay, majority D's, I believe. But again, don't wait till someone else plugs in their answer to see what they put. Just go ahead and plug in what you think it is. And if it's a guess, just put a question mark next to it. No worries at all. So for those of us that gave this question a shot, tell me, do you feel like this question was easy, medium, or hard? Do you feel like this question was easy, medium, or hard? Okay, cool. So hopefully, if we've had some sort of practice or have had some sort of review when it comes to percents recently, then this should good and well feel like something very doable. So let's go ahead and understand and break this down. First of all, if you're in my course for arithmetic reasoning in the ASVAB, you are going to look right here, Unit 4. Wow. Unit 4, percent word problems. This is where you are going to look, okay? So that's where you're going to find these types of questions. So first step is, hey, we're going to go ahead and read the question first. And when we read that, what we see right over here is that it says, how many grams of flour has Nancy used? So everyone, were we able to do that? Even if we were here for the first time, were we able to read that question and just say, okay, we want the grams of flour for Nancy? Was that pretty easy to say confidently? Even if we don't know how we're going to get there, were we able to say that clearly? Okay, great. Let's go and write that down. So we are going to be saying right here, blank grams of flour used by Nancy. And as you get better, you don't really have to write all that down. With more experience, that'll stay right up in your head. But let's get to the most important part here, and it's the formula that you're going to be using. When it comes to percent word problems, there's a formula. And knowing how to use this percent formula, it's going to set us up not just for this question, but for the ones that are going to be following after this one. So here's the formula. That way we can start thinking about this in the right way. So the formula is right here, percent times original equals the result. All right, the percent times the original equals the result. Great job saying that right there, Delilah. So let's go ahead and write that down. The percent times the original equals the result. Now, there is something very, 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 very important that we should write down when it comes to this formula. What is that supposed to be? What is that main idea? If you've been to my classes when it comes to percents, what's that main idea? Landa, on fire already. Yes, the percent you apply is the result that you get. Now, if you, again, have never heard me say this in your life, don't worry, I got you. Here's the biggest key to this formula. When you take a look here, you have 3 pieces. You have the percent that you're applying, the original number, and then you have your resulting number. So what we're saying is that this right here, that's obviously a percent. It says percent, and that's going to be marked as a type of number, a percentage. But the thing is that percent and the amount, the actual number that you have in reality, those are the same thing. Those represent the same thing. So for example, everybody, let me take you through a couple of different scenarios, not just the one that we're doing right now. So pay attention real quick. Let's suppose that I said, hey, 20% of the money that I get every month is rent. So if I took 20% of all the money I make, whatever number this is, if this is $800, well, then my rent is $800. Does that make sense, everybody? If this percent right here represented, hey, the percent of the audience that was female, well, when you apply the formula, this result would be the number or amount of females. They represent the same thing. So yes or no, everybody? Does that quick overview make sense? Cool. I want to see everybody participate here as best as we can because I'm telling you, getting this stuff down now, as simple or as hard as it might seem, getting this down now is going to really rocket propel us later on in a couple of questions. So, okay, good. So let's check out the overall story here. We're looking for the number of grams of flour that Nancy's used. We know that this is a percent problem because it says, hey, Nancy's baking a cake that needs 2,100 grams of flour. She's already added 23% of the required flour. Okay, so they right there, flat out, gave you a percentage. So here's how you know you're using it correctly, everybody. Right here, this percent, I'm going to go ahead and say that's 23% right here. And again, what that means is that's 23% used. She's already added that amount of flour. So percent of flour added. So everybody, what does that mean this result is going to get us? Let me go ahead and make this a little smaller. Let's see if we're getting this down. If this right here, this 23% represents the percent of flour added, what does the result mean? What is that going to give us? What is that going to say? Not just the number, but what amount does that represent? The amount of what used? Right. The amount, the grams of flour used. This would be the grams, whatever this is. I don't know, but this would be the grams of flour used. I'm trying to be so clear on this. All right. I'm trying to be so clear on this for the simple reason being that if you have this formula down, a lot of the percent problems that you thought were confusing before are going to be very straightforward. So let's now talk about what that original number is. My party people, what is the original number in any word problem when we talk about percentages? What percent are we talking about? Yeah, we're talking about 100%. We're talking about the number that represents all of what you're talking about. So everybody, since we're talking about the amount of flour that we're using for this cake, well, guess what? The original 100% is all the flour. Everyone, which number up here represents all of the flour? Right, 2,100. Let me highlight that in green for us. Right here, it needs 2,100 grams of flour. So what that tells us, again, that's the original amount. That's all of the flour that we would be using. So let's write that down right there, and we're good. Now, hopefully, everybody, do you see that to get the result right over here, all we have to do is multiply 23% times 2,100. Are we good with that? Cool. So let's go ahead and check it out. Try it out. Move on. Have a good day. So let's see here. First thing we do, everybody, is we need to do what with that percent? It's the first thing we need to do. Right. We need to turn it into a decimal. So we need to go ahead and start right here. Typically, the way we say it is, well, if you're trying to turn it into a decimal, percents are out of 100. So you divide by 100. The shortcut way is just to move that decimal place over to the left 2 times. That's the other way to do it. So 1, 2. So that becomes 0.23 multiplied by 2,100. And that's going to give us our answer. So let's go ahead and get that done right over here on the side. I'm just going to move over here and just say, hey, 2,100 multiplied by 0.23. And for those of us that are a little removed from dealing with decimals, all we need to do is ignore the decimal and bring back all the decimals at the end. So multiply normally, then bring the decimals back at the end. Step 1, multiply normally. Here we go. We're going to have over here 0 times 3. That is going to be 0. 0 times 3, that's going to be 0. 1 times 3, that's going to be 3. 2 times 3, that'll be 6. Next thing we do is we're going to drop a 0 to try to get to this next digit here, the 2, and we keep it going. 0 times 2, 0 times 2, 1 times 2, and 2 times 2. So far, before I move forward, everybody, are we still good? Are we still good? We just multiplied like normal. We get the end result. Are we good so far? Sounds good. So that was step one, multiply normally. Step two, we said we would bring all of the decimals back. How many decimals are we bringing back? Two. We are bringing two decimal places back. Observe right over here, guys. Right here, we see that we have the decimal right there. That's one, that's two. So that was two decimal places. So that'll be one, two, brought back. And so that's why this would actually be 483. So the answer is 483 grams of flour used, because the percent that we used was the percent of flour used. So the amount that we get is the amount of flour used. Again, it's all about those connections. It's all about how these keywords and inside of these formulas make sense together. But that's what we'll get. Answer is D, 483 grams. Yes or no, my party people? Did that make sense? Oh yeah, Landon, you can absolutely set it up as a proportion. Yeah, at this point you know that, and that's great. You can feel free to use a proportion any day of the week, because you're literally still doing the same math. So yeah. All right, cool, great. So I'm glad we understood that, guys. I'm glad we understood that. Again, the biggest takeaway, I'm going to sound like a broken record, but I really truly care about your success. It's this: the percent that you apply is the result that you get. Please write that down. If you want to repeat after me one more time, please do. The percent that you apply is the result that you get. They represent the same idea. So, with that, who's ready for question number 2? All right, sounds good. Cool, sounds good. So here we go. Just make sure, again, when you're trying to learn or trying to figure out how to set up that formula, as always, the percent you apply is the result that you get. But I still bet you about half of us are going to be a little confused by this next one, but we'll still see what's up. So let's get my face out of the way. Timer's up. 3, 2, let's party. All right, looking at our final 10 seconds. Feel free, throw an answer out there. If it's a guess, go ahead, put a question mark next to your guess. But I'm really looking forward to see, hey, where are we at? Do we feel like we're confident in this? Do we feel like we need some more review on this particular type? How are we feeling? Feeling confident? Again, put a question mark next to your answer if it's a guess. No worries. Put a question mark next to your answer if it is a guess. And again, even if you have no clue, remember on the ASVAB, you have all the power in the world to take a guess. It's a 1 in 4 shot, 25% chance. Go ahead, give it a shot. Give it a shot. Okay, so first question is this. Everyone, are we still doing the same topic, percents? Are we still doing the same overall topic, percents in this question? Okay, looks like everybody here agrees. Looks like all of us here are saying yes. Sounds good. Now, my follow-up question is this. Is it the same exact difficulty as the question before this one? Is it the same difficulty as a question where you just tried to find the result? Right, not as easy. Not as easy. What makes this different, everybody? We're working blank. We are working what? We are working what? Yeah, we're working backwards. We're working backwards. So again, it is very important to know your formula going forward, but also very important working backwards. So let's go ahead and state that formula out for everybody who may have missed it or just needs to see it one more time. Right over here, remember that the percent multiplied by the original, that's what equals your results. All right, your percent times the original equals the result. And everybody, if you wouldn't mind, in the chat box, whether you're new or this is your 50th class, go ahead and state it in the chat box. What's that main idea with percents that I just talked to you about? What's that main idea? The percent that you apply is the result that you get. Thank you, Landa. Now we need about 113 other people to go ahead and state that in the chat box. Again, I want everybody to really get into this because neurologically speaking, if we're talking about committing this to memory, going ahead and talking about it, writing it, saying it in your head, repeating it, all of that's going to help you in every which way to build connections in your brain to remember this more than just or longer than just tonight's class. I want you to actually understand this as opposed to feeling like you're memorizing something. So again, yep, the percent that you apply is that result that you get. Great job. So with that said, here we go. Let me highlight that again. Percent you apply is the result you get. Let's read through the question. Let's see what we got going on. It says over here, hey, what percent of the cost does he have? So what we're looking for, everybody, is the percent of the cost. Everybody, do we know what amount of the cost we have? Because again, this right here is what we're looking for. But do we know anything else? Do we know the amount of what we have? Do we know what the original 100% is? Do we have these things? Yeah. Answer is yes. Take a look right over here. If we take a look at the information, it says, hey, Brian wants to buy an item that costs $3,100 and he has $2,139. So that tells me right here that he has $2,139 out of the whole $3,100. So this percent that we're looking for, the percent that he has, is connected to $2,139. Does that make sense there, everybody? The percent that we're looking for is connected to what Brian has. This is one of the most important questions, one of the more nuanced questions, but definitely one of the most important ones, because if you don't have that down, you're going to be sitting here hoping and wishing for the best. And we don't want that. We want to actually understand what we're doing. So next up, help me out, everybody. What here represents the original amount, or I guess the original cost of the item? What's that going to be? Exactly. The item costs $3,100 right there. Boom. So hopefully this is pretty straightforward. Apparently we're going to have some percent that when you multiply that percent times $3,100, we are going to get $2,139. Cool. We've set it up. Going forward, if we tried to find the result, we were always multiplying. But this time, we're working backwards to find the percent. So what operation do you think we're going to do? Yeah, we're going to be dividing. We're going to be dividing. And so let's go ahead and get it done. This is all you have to do. All you have to do right here. Let me zoom on in. We are going to see that we are multiplying by 3,100. Well, I want to get this part here by itself. So what I'll do is I'll divide both sides by 3,100. And if you're looking at this like, hey, coach, how are we supposed to divide these huge numbers? Hey, don't worry, relax. Give us a second here. We got you. But first and foremost, what's going to happen on the left side, everybody? What's going to happen to that 3,100? Yeah, on the left side, remember, when you multiply and divide by the same thing, or whenever you perform opposite operations, you're always going to have a cancellation. That was the point. So now over here, we have, that mystery percent is going to be equal to whatever that division is. And this is where we have ourselves in a wee little predicament where we're now going to have to figure out what 3,100 divided into 2,139 actually is. But everybody, if you had to take a look somewhere in the problem, if you had to take a look somewhere in the problem to take a guess as to what that first number might be, because think about it like this: 3,100 can't go into 2, can't go into 21, can't go into 213, can't go into 2,139. So we have to go with those decimal places. So when it comes to right over here, 21,390, that's huge. What number do you think we might want to use? Yeah, if you take a look at the answer choices, what do they all start with? They all start with 6. Are you going to sit here and start guessing 4, then 5, then get to 6? No, use your answer choices to your advantage. You see that they all start with 6. Hey, that's the best number I'm going to guess with. So I'm going to go ahead and say, hey, 3,100 times 6. That's going to be 0 times 6, 0 times 6, 1 times 6, and 3 times 6. So 18,600, that's what we get when we plugged in 6. And so again, that's going to be 18,600. What we'll do now is we'll go ahead and subtract to see what we have left, to see what we can keep doing. So here's what we got. We're going to have ourselves 0 minus 0. That's going to be 0. 9 minus 0 is going to be 9. 3 minus 6 can't do that. So we'll have to go ahead and borrow from 1. 13 minus 6, that's going to end up being 7. And then we have 0 minus 8. Can't do that again. So we're going to have to take from the 2 over here, make that a 10. 10 minus 8, that's going to be 2. And then 1 minus 1 is 0. So we have 2790 here. Now we have to go ahead and drop that 0. Let me move this over to make sure I show this correctly. There we go. Let's drop that 0. So now we're trying to go into 27,900. What number might you want to guess? What are we thinking? Thinking of 9? That's possible. That's possible, everybody. And if you're asking, hey, how did we get 9? Here's a good way to look at it. Here's one way to look at it. If I'm taking a look at this as, 3,000 trying to go into 27,000, I'm going to ignore the 100 and the 900 for a moment. I'm going to say, 3,000 and change going into 27,000 and change. Everyone, 3 goes into 27 how many times? Yeah, 3 goes into 27 9 times. So it might be a fair guess. It might be in the ballpark to guess 9. It might be there. We can't find out until we actually confirm and try it out. So let's do our due diligence and let's see what we got. So I'll say 3,100 multiplied by 9. Let's try that out here, right over here next to me. So 0 times 9, then 0 times 9 again, 1 times 9, 3 times 9. Everybody, were we correct? Were we correct with our guess of 9? Yeah, absolutely correct here. Absolutely correct. So with that, booyah, that's going to be 9 right there. And so we subtract the 27,900. That's going to be no remainder. So we have 0.69. That is our answer. And remember, everybody, when you solve for a percent inside of an equation, every single time it's going to be in decimal format because you need to calculate with the decimal form. So this right over here, that is a decimal. That is a decimal. We need to turn that back into a percent. If we get to a decimal by going to the left 2 times, how do we go back to a percent? That's right. We're going to move it back to the right twice. So right over there, we take that decimal place, 1, 2, and that ends up being 69%. So we now know that Brian, with all that money he has, that is only 69% of the cost of that item that he wants. Yes or no, my party people, does that make a little wee bit more sense? The answer would have been C. And for the person asking where the 9 came from over here in this part of the question, when we're doing long division, there are times where you do need to do a quick little bit of guesstimating to see what numbers that might be. That helps you, especially when you have large, uncomfortable numbers, like trying to divide into 2,139. That definitely helps. Is it possible to plug in answers? Absolutely. But that it's going to take an excruciating amount of time. And given that if you don't know how this works forward, then it's going to be highly unlikely that you know how to plug those numbers in. But if you understand how those answer choices work, yeah, go for it. Go for it. If that's your play. Okay. So these first 2 questions here were warm-ups. Okay. One was going forward to figure out what the result amount was going to be. And then one was going backwards like this one here to find out what that percent was, to go backwards. Now, let me go ahead and read some of these comments or questions, and then from there, we will move forward. So with that, I may admit this person. So yeah, the division was confusing. Sounds good. So for those of you who felt that the division was confusing, do you feel that the division was confusing because we were working with larger numbers, or do you feel like it was confusing because you just need to brush up on your division skills? Which one do you feel like it might be? Gotcha. Not that good at division. I struggle. Feel like you need to brush up. It's the larger numbers, brushing up, recapping the division, brushing up. That's your weakness. Larger numbers for sure. Okay, cool. So here's one of the great things, the great advantages that you have when it comes to studying in a group like this. When you discover that you're having an issue with a fundamental idea meaning, okay, working with big numbers, small numbers, decimals, fractions, percents, order operations, solving simple equations, like those fundamental core ideas, when you see that you're having trouble with one of them, take a note of it. Write it down on your paper, take a note on your phone. Make sure that that is something that you attack and continue practicing, because any question that you see could show you large division. Any question you see could have a decimal. Any question you see could have a fraction. You need to make sure that you're prepared for those moments as opposed to avoiding the pain of growing and then paying for it when you take the actual test. Does that make sense, guys? Okay, cool. Remember, it's going to be hard now, easy later. Trust me. But here's what we're going to do next. What we're going to do next is we are going to move forward with these mixture questions like I previously warned you of. Now, I use the word warning because this may be particularly tough for some folks, but I'm going to do my best to explain this in a manner and escalate it in a manner that gives you a really good shot at practicing from the very beginning all the way through, even the backwards version of what we're about to do. But first, as always, do what you can with the time you have. And then from there, I'll reconvene with you and I'll really lead the way and help you understand this. So with that, let me go ahead and admit these folks here. Perfect. All right, so let me go ahead and get your timer up and let me raise this up to 3.5 minutes. Cool. And there's your timer. All right, and I will go ahead and say good luck to you, my friends. 3, 2, 1. Start it off, my party people. Give it a shot. Jocelyn, the way that you can test it out with the answers is by applying the percent in the answer choices to the original amount. So it would have been, 64% times 3,100. Does that give me 2,169? Then it would have been 68% times 3,100. Does that give me 2,169? And you keep going until you get that. No worries. Go ahead, everybody. We'll be back in 3 minutes. All right, in moment of truth, we are at our final 4, 3, 2, plug in your answers. If you don't feel like you have a solid answer or not a confident one, go ahead, put a question mark next to your answer. Put a question mark next to your answer. Take a guess if you need to. I do not care. We are here to do anything and everything we can to maintain a sense of confidence and preserve that sense of confidence throughout our practice. Okay? And that includes admitting when you just don't know what you're doing. When you're practicing, especially, there's no point in just like throwing spaghetti at the wall when it's much better to admit that, hey, in this moment, I feel like I'm taking on a little more than I can handle. Let's see what the building blocks are so I can try to come back and tackle this again. So before I continue, does that make sense, everybody? Does that make sense? Admitting when you are confused is a very important part of your studying process. Okay, good. Okay, so basically, everybody, here's the thing. There are going to be 2 fundamental facts that I know that you know that I know, we know that we both know. 2 facts that I'm going to use to show you how to get this question done correctly. Now, before I continue, I want to make sure that you understand if you're on the same boat as everybody else or if you are completely unique to the situation. Everybody, was this question easy, medium, or hard? Was this one easy, medium, or hard? Okay, the first person, second person, third person, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 13 people in a row said hard only because the next person said, I don't know, followed by the next 20 people to say hard. I don't think anybody here said that this one was easy. Draco, I hope you're trolling, or I hope you're not trolling, actually. So let's go ahead and try this out. Everybody, what are we looking for? First question, what do we want? Did you forget about that? Your training? Read the question first. What is it that we want in this question? Can you tell me what we want? Okay, Jimmy, oil concentration. Duarte, oil concentration. Janae, oil concentration of the mixture, resulting mixture, oil concentration. What does that mean? Can you give me a math word that might be hinted at? What does that represent? What do you mean? What does concentration mean? What does that mean? It might start with the letter P. It might be represented in the answer choices. What is it that we are looking for? Let's be very clear here. What are we looking for? A percent. We are looking for a certain percent. Everybody, before I continue, yes, oil concentration of the resulting mixture. That is absolutely correct. I'm just making sure that when you say that, you know what that means. Okay, I want to make sure that you understand what oil concentration of the resulting mixture means. So, first step, if we're thinking about this mathematically, the answer choices do a great job of graciously giving us the type of number we're looking for, and that is a percent. So, do we agree, everybody, before I continue? We are looking for a percentage. Okay, great. Sounds good. Now, to be more specific, that percentage, like we said, represents the oil in the resulting mixture. So what we're looking for right over here, everybody, is the percent oil in the mixture. Okay, everybody. Sounds good. Now, here's the thing, everybody. If we wanted to find the percent of oil in the resulting mixture, if we're thinking purely in terms of the formulas that we've been used to using, let's actually write it out just to remind ourselves. Percent, oh, Jesus, that's a little too skinny. There we go. Percent times original equals result. So help me out, everybody. Help me out. Is it true, or not that is it true, but if we're looking for this right here, a percent, and that percent represents the oil in the mixture, what other thing here, original or result, which one of those other things would also represent the oil in the mixture? Which one of those would it be? Help me out. It's almost like we just went over this. It's almost like we just went over this. Yeah, it's going to be the result. Remember, repeat after me. The percent that you apply is the result that you get. So what that means in its entirety is that, hey, if we're looking for this right here, the percentage of the mixture that is oil, then if we're trying to set up the formula, we should look to find out what the actual amount is of the oil in that mixture. Does that make sense, everybody? One possible way we could solve this, if we're looking for the percent of oil concentration, we might want to be looking for on the side the amount of the oil concentration, right? Cool. Now that we're done with that part, here's the second fundamental fact, and this fact is a lot easier to understand than this first one. I can guarantee you that right now. Let me tell you this right here. Everybody, we see that we're talking about, this 50 milliliter solution contains this much oil mixed with this solution that contains that much oil. Basically, everybody, is it true that we have, let's go ahead and say solution 1, solution 2, you combine them and you get the mixture. Is that fair, everybody? Is that fair? Can we simplify that? Because that sounds like a lot of jargon, a lot of gibberish. Basically, all that's saying is, hey, you got solution 1, solution 2, we mix them together, we added them together, and we get this mixture. So that's the fact. Here's the fact that I'm going to draw from that. The fact is this. is oil in solution 1 plus the oil in solution 2 equals the oil in the mixture. Is that a true statement, everybody? Is that a true statement? The oil in solution 1 plus the oil in solution 2 equals the total amount of oil in the mixture. Is that a factual statement? And I want everybody to respond. I want everybody to respond, because I can guarantee you the moment that I expect some of you guys to have questions, I'm going to point it right back to this. I'm going to point it right back to this every single time. Okay, so let's let that sink in for a second. Let me move this over here. That way we don't hear that again. But don't worry. So don't worry here. Let's go ahead and just gather ourselves. I'm really excited to see how much of y'all are going to have this light bulb moment. Now, the following question is this. Let's see how we can use, or how can we use the information we have to figure this out. Because everybody, I don't think that the problem, if we read through it, I don't think they actually tell you the amount of oil in solution 1 or the amount in solution 2. Heck, they don't even tell you the amount in the mixture. So what do we need to do? Let's read over here. A 50 milliliter solution that contains 40% oil is mixed with an 80 milliliter solution that contains 25% oil. Look at that. In solution 1, they didn't give you the amount of oil, they gave you the percentage of oil. For solution 2, they don't give you the amount of oil, they give you the percentage of oil. Everybody, think about it. If we wanted to find how much oil was in solution 1, couldn't we use the percent of oil in solution 1? Couldn't we use this right here, the 50 milliliters, 40% of the 50 is oil? Couldn't we use that? Couldn't we use that? Yeah, we could do that. We could do that to find the amount of oil in solution 1. How about with solution 2? Same idea. Right here, 80 milliliters contains 25% oil, so that's 25% of 80. I can plug that in right there to find out the amount of oil too. Boom, I got what I need. And then I can just replace this right over here with the same thing, the same formula. Percent times the original equals the amount of oil in 1. Percent times the original equals the amount of oil in 2. Percent times the original equals the amount of oil in 3. Everybody, is this making a little more sense to you, or do you need to see it actually written out? Is this making a little more sense, or are we still saying that we need to see this? Okay, about half and half? Good. Okay, so let's go ahead and really partition this and show this on paper here. So allow me to just make some more room just in case. One moment, guys. Right there. That should definitely be more than enough space. So allow me to just copy this and really lead the way. Okay, right there. That's great. Okay, cool. So let me write this out for you. Let me zoom in. So the oil in solution 1, again, think about it like this. Percent times original equals the result. So right here, this is the result. If we're thinking about the percent times the original, this right here is going to be 50 milliliters. That's the original amount, and that's the percents. 40% of it is oil. So I'm going to say 40% of 50. Right here, percent times original. That's 40% of 50 milliliters. Everybody, is that making a little more sense there? What we're doing is, instead of writing the result to find out what that is, I'm just going to do the percent times the original. Then I'm going to figure out what that is to plug it in. And I'm going to do the same thing for the second, do the same thing for the third, and it's really going to play out nice and smooth. Just allow me a few moments to actually set up the math and do it. And I promise you, you're going to see how it all comes together at the end. But the main part of this is, again, When we're talking about a result 1 plus result 2, well, you can go ahead and say that that is the percent times the original there, percent times original here, because we're talking about percents. Here we go. Oil in solution 2, let's figure out what that's going to be here. Let me use green. Everybody, what do we have for the original amount for solution 2? What do we have? What's the original? Great. Yep, that's going to be 80. We're told that the original amount of solution 2, 80 milliliters. And then what is the percent in solution 2? What is the percent in solution 2? Right, that's going to be 25%. Nice and easy. So let's go ahead and now copy that down here. Again, the percent times the original is going to give us the result right here. But this result, again, is going to be 25% of 80 milliliters. Great. Now here's the final part. This is the trickiest part. So pay careful attention here so you don't get confused. Everyone, what information do we have about the oil in the mixture? What information do we have? Like about the combination. What do we know about the combination? Do they give us the original amount of that combination? Do they give us the percent of that combination? Do they give us the amount of that combination? Do they give us anything at all? Do they give us anything? Did we? So basically what I'm asking is, did we highlight all the numbers already? Yeah, we already highlighted all the numbers. We highlighted the 50, the 40%, the 80, the 25%. There's nothing else there. And this is the part where so many people get confused. But remember, everybody, what are we talking about? We're talking about a mixture. So everybody, how do you obtain a mixture? What do we do with solution 1 and solution 2 to get the mixture? Yes, we added them. So when you're asking, hey, everybody, guess what? We're looking for the percent. That's right there. Those are the answer choices. I am looking for the percent. But what is that percent of, everybody? What is the combination of 50 milliliters and 80 milliliters? When we put those together, what is the total amount of that mixture? Yeah, 130. So that's what happens there. 50 and the 80, that's going to come together to give you 130 milliliters inside of that mixture. Does that make sense, everybody? The easy way to go ahead and get the original amount or the total amount of the mixture is to add what's in 1 and 2. And that's it. That's it. Now that you've set this up like this, it takes a lot of thinking and you got to understand how percentages work. But once you get here, it is really smooth sailing because right here, watch, let's do the math. We are literally here saying 40% times 50 plus 25% times 80 equals X percent times 130. That's your equation, and watch how straightforward it is now. First, start off 40% times 50. I'll put that decimal place right there. We have 0 times 0, 5 times 0, nothing happens. Then we have 0 times 4, then 5 times 4. Then we have 2,000. But everybody, how many decimal places are we moving back? We're moving back 2 decimal places. So that's going to end up being 1, 2, 1, 2. So that right here, this becomes 20. So that is the amount of oil in that first solution. That's what that 20 represents. Now let's take a look at the second one here. We have 25% of 80. So I can do the math right down over here. If you know your mental math, you know that this is going to be 20 as well. But let's go ahead and plug it all in. 0 times 5, 8 times 5, that's going to be 40. Bring down a 0. 0 times 2, 8 times 2, and that's going to be 16. Add this all up, and then we have ourselves 2,000. But everybody, how many decimal places do we bring it back by? We bring it back by 2. So that's going to be, again, 1, 2, 1, 2. But nonetheless, what color was that? green. So, yep, boom, plus another 20 equals whatever X percent times 130 was. Everybody, what's 20 plus 20? Hardest question of the day. Okay, 40, great. We got 40 equals X times 130. Everybody, is this solvable? Is this possible to solve? What are we supposed to do? We did all this work. We got to this point. This might be a lot easier than the other steps. So what's the one thing we need to do to both sides here? And again, the X and 130 are being multiplied. So how do we work backwards to get the X by itself? That's right, my party people. We got to divide on both sides. And remember to always include that both sides argument because you don't want to get lazy with the way that you talk about it. So we can stay focused in terms of those pressure moments. But right here, divide 130 on both sides. And there you have it. Boom. Now all we need to do, all that's left is to figure out what 130 into 40 is. So let's try this out. 130 can't go into 4, can't go into 40. It could go into 400. How many times can 130 go into 400? Think about 13 into 40. How many times can 130 go into 400? How many times do you think? Yeah. Yep, going to be 3. And if you need proof on that, no worries, I got you. You can say, hey, 130 times 4, or times 3, excuse me, just to try it out. 0 times 3, 3 times 3, 1 times 3. 390 is pretty close. 390 is pretty close. So we'll go ahead and put 0.3 right there. Subtract 390. We got ourselves a remainder of 10. We'll bring down the 0. Everybody, can 130 go into 100? Nope, it cannot. So we got 0.30. Let's see if any of these answer choices matched out already. Which answer choice is it? Yeah, D is the only one. D is the only one that went 3, 0 right there. That's the only one. We could have kept going, but we don't need to anymore. We don't need to anymore. So my expectation is that even though we went through that solution, this is probably still on the upper level of difficulty for you. Is it still fair to say that this problem is still a very hard question? Okay, yeah, totally understandable. Because what we're doing is we're mixing the idea of percentages into a general scheme, and that can be very difficult, particularly if you don't have your foundation set. So that's why I've prepared to give you 2 more types of questions just like this one to really help you practice this, excuse me. Again, the point of this all is not to memorize these questions. It's to really gain an understanding, even when it feels hard. So let's try this out again. Let me review this with you from the beginning. Everybody, what did I say in the beginning? I'm going to repeat myself. 2 facts that we were drawing off of. The first fact was what, everybody? Percent times the original equals the result, and that the percent and the result represent the same thing. Yes or no, everybody? Was that fact number 1? Was that fact number 1? I said percent times original equals the result, and the result and the percent represent the same thing. No worries, Prince. I gotcha. Okay, and here was fact number 2. Fact number 2 was, hey, if I have this much oil in solution 1 and this much oil in solution 2, to get how much oil they have together, I just got to add them. That was fact number 2, yes or no? That was fact number 2, yes or no? Good. So this is what we did with that. This is what we did with those 2 simple yet completely unmovable truths. We simply said, hey, I'm going to make this equation here. Oil in solution 1 plus oil in solution 2 equals the oil in the mixture. We said, hey, coach, that's A-okay. Now, what I did beyond that was, hey, if we want to find the amount of oil in solution 1, that's the same thing as doing the percent times the original. That's the same thing. So we just pulled the numbers. All we did was pull the numbers, and we said, hey, man, right over here, let me use my pointer. This is actually a little easier. We said, hey, in solution 1, 40% of the total, that was oil. In solution 2, 25% of the total, which was 80, that was oil. So we can find out the oil in 1. We found that. We did the math. That's 20. For the second one, did the math. Okay, just so happened to be 20 as well. And that's going to represent the percent times the original of the whole thing. And since we were looking for the percents, boom, all we had to do was just plug and chug at that point. Once we got the equation to make sense, the rest of it was just following the path that was set for us, which was, hey, compute this, compute that, add these together. Then once you have your little equation here, get the x by itself, get that percent by itself. That's what we did, dividing 130 on both sides. And then a couple of more moments later, a couple more math sentences later, we get the answer. But it all came from those two fundamental facts. Again, percent times the original equals the result. And number 2, hey, if we're mixing something up, we're adding things up. And that's what happened there. Right, it's really just a process. The main thing that I really want to get out of this is that this is a process. This is what a mixture percent problem really looks like. When you're combining an amount from this percentage, an amount from this percentage to get a combination of percentages. What a lot of people want to do, and you guys tell me if this is what you wanted to do. A lot of people want to take the percent that they see there and the percent that they see there, add them up, and hope that they see that number in the answer choices. Did anybody here do that? Naelia instantly was like, yep. And a few more, yeah, about half of, more than half. That's how I got B. Yeah, some people may have tried to add up the percentages and then cut it in half to get an average. And that's the thing. You're going to think that that works, but it doesn't, because when you're adding them up and dividing by 2 to get an average, you're assuming that they came from the same weights, but they didn't. One was 50 milliliters. The other one was 80. So that means that the percentages had different weights. So you could not do that and calculate the average. That's a trap. So do we see why that wouldn't work, though, everybody? Do we see why that particular strategy would not work? Yeah, I got you. Again, the point of this is to grow from every single experience. And I know this question is hard. That's why I want to spend some time on it. Cool. Okay. So again, I appreciate you guys sticking through this, because one of the biggest things that I'm afraid of is losing someone who is right there on the cusp of getting the help that they need. So when I run these harder questions, I run the risk of alienating somebody who feels like they can't get it at all, even though you guys know that we're supposed to be trying our best and nothing more. But I want to give you guys the opportunity to try another one of this same exact type. I want you to try another one out. And all I want you to try to do is get the setup. Okay, everybody? Just the setup. If you want to continue going and getting the math and getting the answer, sure, great. Do your thing. But I only want you to try to get the setup correct. Okay? Cool. Jocelyn, not always. Because notice how this question had you calculate the percent of the resulting mixture. So that's what we would have had on the right side by itself. But what if they would have said, what's the percentage of solution 1? Can you set that up? Can you set it up? So that's what this next one's all about. Let me get my face out of the way. Let's get this set up. 3, 2, 1, 3.5 minutes. Try it again. I hear you, Jamaica. So you said you want me to slow down because you're still processing the long division. I gotcha. So once we get to the point of setting this next one up, I'll go back up so you can take a screenshot of the previous one. Actually, everybody, if you want to take a screenshot of the previous question, I will pause the timer. I'm going to go back up and I will let you take a screenshot starting here. I'm going to count to 7 seconds. 3, 4, 5, 6, and 7. And then I'm going to scroll down slowly, allow you to take a screenshot here. This should be the rest of the question. Another 7 seconds. 3, 4, 5, 6, and 7. All right. Hopefully that was enough time, guys, to let you take a screenshot of that previous one. And again, use those notes. Let's see if you understand how that setup is going to lead in with this one. You're welcome, guys. I got you. Resuming now. 3, 2, and 1. And your final 2, 1, and time. All righty. How are we feeling about this one? How are we feeling about this one? Any better at all? Was the previous question a good template for this one? Cool. So here's the good thing about being able to do this more than once in class. What I'm going to be able to do now with you is I'm going to be able to take you through the root of the problem as opposed to taking all that time in the setup. So everybody, if it's fair with you, I'm going to reiterate the same points that I made in the previous question, which was again, hey, the percent times the original is the result, and other right over here, if we talk about oil in solution 1 plus the oil in solution 2, that's going to give us the oil, the total amount of oil in the mixture. So this is really the biggest thing you have to understand, guys. This right there, that's the biggest thing that you have to understand. The oil in solution 1 plus the oil in solution 2, when you add them together, that's going to give you the total oil in the mixture. So before I continue, yes or no, are we good there? Because from there, it's the setup, the math, and we're done. Okay. And I'll wait for a couple more folks. No worries there. So look at how crazy this can be. We're playing off of this one simple fact, and now we need to throw the percentages in there. So how do we get the amount of oil in solution one? We do that by saying, hey, we're going to do the percent of the oil in solution one times the original amount of solution one. And so that right there is 70% of 30 milliliters. Everybody, do you agree with me? That's how we get the amount of oil in solution one. We do the 30% times the 70% times the 30 milliliters in the solution. That's how we get oil one. Cool. That's how we get the oil in solution one. Now, let's go ahead and talk about the oil in solution two. For solution two, we see that it says, hey, it's mixed with 80 milliliters over here, and that 80 milliliters is 75% oil. Sounds good. So that would end up being right over here, 75% of 80. Again, all I am doing here, everybody, is replacing the result with what its part is in the formula. As I said before, the percent times the original equals the result. So instead of just writing the result, I replaced the result with percent times original. I replaced the result, the amount of oil, with the percent times the original. Are we starting to see that now? Everybody, are we starting to see that now? All I'm doing is replacing the result with the percent times original. Replace the result that I don't know with percent times original so I can figure it out. And then here, to get the oil in the mixture, that's what's going to be the blank percent that we're trying to find times the total amount of the solutions. Everybody, how much total do you have now? What's the original for that entire mixture? Right, that's going to be 110 for all of them. Yep, because you had, again, 30 milliliters in that first one. You had 80 in the second one. 30 plus 80 is 110 total. So we get this plus this equals 110 milliliters. You got stuck there to add. Boom. So again, now we'll be able to see that in the future. We'll be able to see that as we continue moving on in the future. So now that we're here, all we have to do is the math. Like if you got to this point right here, my party people, I'm proud of you. You know, it means that you've done an extraordinary job in just one problem, being able to fully adapt and get this done or get this set up. So if you got to this point, again, you know, give yourself a pat on the back. If you were not quite there, if you said, hey, I just missed the total, adding them up, or I just missed this one piece, hey, still give yourself a pat on the back because now you're just one step away. So again, give yourself that props. Give yourself that props. So here, let's go ahead and figure this out. 70% of 30, everybody. That's actually going to end up being 21. With a shortcut when dealing with percents, I could show you, instead of doing both of these here, you could just do one here, and that's 7 times 3, and that would be 21. If you didn't know that, well, there you go, surprise. That's definitely something that I would recommend you do. Just like I always recommend understanding how to work with fundamental percentages that are really common, like 75%. 75% is 3/4. 3/4 of 80, that would be 60. But again, I'm not here to try to confuse you like a wizard. I'm just trying to show you that, hey, when mental math can be used, you should use it. So I'm going to backtrack, and I'm going to go ahead and show you the calculations. So right over here, I'll show you the 70% of 30. That would be 0.7 times 30, and I'll do that right here. So 0 times 7, that's going to be 0. 3 times 7, everybody, what's that going to be? Help me out. Yeah, that's going to be 21. How many decimal places do we move back? We move back just one. Sounds good. Booyah, and that'll be 21, like we just said. So did anybody understand the mental math that I used when I said instead of moving the decimal place twice, you can move it once there and once on the other, and it'll still get the same result? Cool. Again, that's just part of mental math that I would really encourage you to adapt to your practice. Number 2 over here, the green, 75% of 80. Again, with mental math, you can see that it's 60, but we can just go ahead and do 80 times 75 or 0.75. 0 times 5, 8 times 5. 0 times 7, 8 times 7. And that's going to be 0, 0, 10, and 6. And so everybody, how many decimal places are we moving back? Yep, that's going to be 2. 1, 2, 1, 2, right there. So boom, that's the 60 that I said. So one more time before I continue, do we understand the importance of mental math and how it can help you become a better mathematician? Cool. Yeah, in your head, boy. Exactly. Cool. So with that, here we go. We are going to go ahead and write out 21 plus 60. Everybody, 21 plus 60 is going to be what? 81. And Tyler, to answer your question, boss, we know how many times to move the decimal place by how many decimals there were moved. So over here, we only had 1. So we only moved back 1. Over here, we had 2. 1, 2. So we came back right over here. 1, 2. Tyler, let me know if that makes sense. Good question. Cool. So now that we're here, we have 81, again, equals that mysterious percent multiplied by 110. And so basically what we're saying is, well, the percentage x times 110. So we can just change that to 110x. But either way, everybody, what do we have to do to both sides? Right. Either way, we have to divide both sides by 2. So let me add another page here just in case we need any more room. But yeah, we're going to divide both sides by 110. And that's it, guys. That is it. We have 81 divided by 110. So we can just say 110 going into 81.00. Everyone, how many times does 110 go into 810? Right, that's going to be 7. Think about the 11 that's in the front. 11 times 7 would be 77 or 770. If you did 8, that would be 880. That's too much. So we want to think about the 7. That's going to be the right one. So we'll put 0.7 right there. You're going to get a remainder of right here 40. Drop that 0. 400. How many times does 110 go into 400? Right, it's going to be 3 for 330. So at this point, I'm just going to stop right here because it looks like we might be going in a loop forever in terms of having more and more numbers to divide. So I'll stop at 0.73 or just about 73%. Because if I go back up, which one of these is the only one that actually starts with 73%? Yeah, the only one is A. Only one that starts off with 73% is A. So if there's anything that I could call truly torture relative to what y'all have been doing recently, this is probably going to be it. So my question is, how much more sense did the second time around make to you? How much more sense did the second time around make to you? A lot more sense? Let's go. Let's go. Let's go. I want to do my war cry right now. Woo! So the way that we got 110 was, and again, these are great questions, guys. Don't stop asking them. So we got 110 right over here by thinking about the essential foundation of the problem. We were saying, hey, if you add the oil from solution 1 and the oil from solution 2, you get the oils added up. And so when we thought about the formulas, percent times original, we were saying, hey, 70% of 30 milliliters, 75% of 80 milliliters. And so this percent in the resulting mixture is a percent of the total mixture. And what's the total going to be? Oh, you had 80 milliliters here. You had 30 milliliters here. 80 plus 30. That's where that 110 comes from, excuse me. That's where the 110 came from. Yeah, I got you guys. Like, you guys are asking great questions. Like, remember, the class goes as good as much as you want to participate. As much as you want to participate, that's as good as the class is going to go. Because if you're just sitting here nodding, saying, yeah, it makes sense, coach, and it doesn't, well, guess what? You're wasting your time. And I don't want that. I want you guys to get every bit of knowledge as you can out of this. So ask the questions as hard or as easy as they are to ask them. I got y'all. So with that, Here's the biggest thing. Yeah, you got to put in that effort. Exactly. So here's the biggest thing, everybody, that I want to ask you about this question. Do you understand why it is not appropriate to try to find the average of the percentages or try to add the percentages or do anything directly with the percentages? Do you know why that is wrong? Yeah, I'll zoom on a little bit. I got you. Okay. So some of us are saying yes, some of us are saying no. Even though we are using those principles, we need to understand the why. And here's the why, everybody. When we go back to fractions, who here has ever been to one of my classes on fractions and has heard me talk about fractions like boxes of pizza? Who here has ever heard me or remember me talking about fractions like pizza? Like the denominator is the number of slices that can fit in your box or the number of cuts you made, right? So on YouTube this morning, let's go. So here's the thing. The reason that you can't straight up, Brian, I hope you're done with this. The reason you can't straight up just add the percentages is because they're from different pizza boxes. Look over here. Right here it says, hey, 30 milliliters. That 70% corresponds to 30 milliliter total. This 75% corresponds to an 80 milliliter total. So those totals or boxes of pizza are different shapes and sizes. They cannot be mixed together in that way by just taking the percentages because their totals are not the same representation. Their denominators are not the same representation. Does that make a little more sense? You can't just take those percentages and add them because they're not of the same total. That's why. And that's the temptation. The temptation is, hey, let's see if they'll just go ahead and add those percentages. Let's see what they do. And that's the trick. That's what these test makers want you to go through. So with that here, everybody, I really do appreciate you guys staying as far as you have because I know these are hard. But are you guys willing to try one more of these out before moving to the next type of question? Are you willing to try one more out? I got you, Fiona. Yeah, exactly. So they trapped you into doing that. So Daphne, if you want to go ahead and shoot me a text of your work, I could help you see why it was that you got the division incorrect. But I would definitely recommend reviewing long division. And at this point, it's 7:35, so I just want to make a quick little, halfway mark announcement. Remember that if you are interested in the full program, just stay till the end of class. Again, our 4th of July holiday sale ends tonight. It's the last day, so you can still get 20% off any plan. So just stay till the end of class, and I will talk to you about that. All right. I want to get back to the action here, though. Let's go ahead and set up another 3.5 minutes. Let me see if I'm not missing any questions. Cool. Sounds good. Emmanuel, there you go. Emmanuel, I'm going to give you 5 seconds. Now let me go ahead and set up this timer. I see how good we got it, guys. Emmanuel, hopefully you are good. All right. 3, 2, and 1. Let's go. Again, this one's slightly different, but if you've been paying attention to the setup, this is the same exact problem. All right, and we're looking at our final 10 seconds here. Go ahead, plug in your answer. Let's see what you got. And again, if you're taking a guess, take a guess. Taking a guess, no worries at all, man. What I'm here to do is help you understand where those mistakes may be coming from. And if it's not even a mistake, if it's just a complete misunderstanding, help you evaluate, hey, how can I move forward from where I am? So let's go ahead. Everything that we do, let's make sure that we got a good head on our shoulders. So everybody, yes or no, is this a similar question to the previous two? Is this a similar question to the previous two? Right? Yeah, it's pretty similar. We're talking about percent mixtures. So yeah, this is definitely this, yep, percent mixture. Let's write that out right over here. This is still a percent mixture question. And if you are in my program, this is going to be AR Unit 13. Unit 13 is the very last unit with your advanced word problems. So if you've been looking at this thinking that this is really out of your range, don't worry. It's the very last unit of my arithmetic reasoning course with the hardest of the hardest questions you'll see. So don't worry. But if you're starting to understand where we're coming from with this, then you're not hopeless. Like, you have a really good shot at really rebounding and getting this done. Let's go ahead and see what we got. So my party people, again, like we said, this is pretty similar to the previous question, but there's a slight difference. Everybody, true or false? In the previous two questions, we were looking for the percent of oil in the total mixture. In the first two questions of this, we were looking for the percent oil of the total mixture. Okay, now let's see if that's the same for this one. What we see here is this. What is the sugar concentration of the 60 milliliter solution? Everybody, is the 60 milliliter solution, is that the total mixture? No, it's not. This is one of the parts. Does it change the setup? Not at all. Not at all, everybody. The setup stays the same. The setup is, hey, what is this talking about? A mixture of sugar. Okay, so we're going to be saying, hey, sugar in solution 1 plus the sugar in solution 2 is going to equal the sugar in mixture. Everybody, is that true? Is that still true? Is this still going to be true? Is that still going to be true? Yeah, it is. I know some of us are a little apprehensive toward this, looking at this thinking, yeah, it looks similar, but I still don't know what to do, for the simple reason being that we changed one detail. But don't worry. What were the facts that we said applied? The facts were, hey, the amount of sugar or oil in the first one plus the second one is the total of them. That's a fact. The other fact was percent times the original will give you that result. So notice that we're still playing off of the same two facts. One, the fact that we all know is true about percents, and the other one, a fact that we needed for this question, a very obvious fact, but one that we needed to remind ourselves of in terms of this plus this equals the mixture. So now that we know that, watch, same exact details. We'll go ahead with part 1. We see that it says a 60 milliliter solution is mixed with a 20 milliliter solution that is to create a mixture that is 33.75% sugar. Okay, so what this is telling us is that, well, the information is not in the same order. You got to be a little more careful. We have a 60 milliliter solution and we have a 20 milliliter solution. Let's highlight these differently. So when you read this, you have solution 1, solution 2, and then you create a mixture, and that mixture is 33.75% sugar. So my party people, this right here, this, let me go ahead and use green, blue, green, let's use purple. This is the percent of the mixture, everybody. Does that make sense? That 33.75 is, again, 33.75% times an amount. That's what we have to make sure we take into account. My party people, what is the amount? What's the total? What's the original for the mixture? For the combined mixture, what's that going to be? And how do you know? Exactly. We have to add them. We're going to add the 60 milliliters from solution 1. And then we have the 20 milliliters from solution 2. That's going to create a total of 80 milliliters for the solution, for the mixture, excuse me. So let's go ahead and fill in the gaps here because we have a percent that we need to multiply here and a percent that we have to multiply there. But so far, everybody, do we see where the pieces went? We are looking for the percent of the 60 for solution 1, the percent of the 20 for solution 2, and then we have the total percent mixture. And since we know that that's 60 and that's 20, that's 80. That is the total. So far, are we good? Yes or no? What's another number now that we can plug in? What's another number that we still haven't filled in? The 75%. Exactly. We haven't filled in the 75%. Where does it say the 75% sugar is related to? Right. They tell you specifically right here, everybody. This 75% sugar, that is for the 20 milliliter solution. So we need to plug that in right there. And now you see, everybody, take a look. Look at the question. What is the sugar concentration or the percent for the 60 milliliter solution? The only thing that's blank is right there. Does that make sense, everybody? Does this setup make sense to you? Cool. Sounds good. So here's the idea, everybody. Whenever you're dealing with a percent mixture problem, you'll do the percent formula for the first idea plus the percent formula for the second idea is going to be the percent formula for the mixture. That's what it is. As you can tell right here, percent times original plus percent times original equals percent times original, but of the totals. So hopefully that makes it just a little easier to kind of bear. But now it's the same exact thing. Plug in your numbers, calculate, and move on with your life. Watch this. So I'll just go ahead and say X here. So we'll have, 60 milliliters times X. Everybody, let's go ahead and do 75% of 20. What's that going to be? Let's figure that out. You add in a little more room just in case. So we'll go ahead and do 75 times 20. That's going to be 0.75. So we'll go ahead and do 5 times 0, 0. 7 times 0, 0. Next line, 5 times 2, that's going to be 10. 7 times 2, that'll be 14. Carry the 1, that'll be 15. Add those together, and that's going to be 1,500. Everybody, how many times are we bringing that decimal place back? Absolutely, 2 times. 1, 2, 1, 2. So we have ourselves right here, 15. So we have 60x plus 15. And then it's going to be 33.75 times 80. Okay, sounds good. So in case you didn't know, well, I'm just going to preach mental math, but let's just go ahead and go through it. Let's figure out what that's going to be now. This ugly stuff right over here, yes, we still have to calculate it. And the easiest way to do it is going to be 33.75 up top. So let me do that right over here. Okay, so it's not as bad as you think because we have 5 times 0, 7 times 0, 3 times 0. So it's all going to be zeros for that first row. You're fine. It's the second row that you really have to be careful with. So let's go ahead. Let me just grab this and move it over. So we have 5 times 8. That'll be 40. 7 times 8. That'll be 56. Plus the 4. That'll be 60. 3 times 8. That'll be 24. Carry the 6. That's 30. 3 times 8, 24, carry the 3, 27. So that's what I meant when I said be careful because it looked clean and it was clean. We had to carry all those digits. So with that said, boom, add these together. We have 0, 0, 0, 0, 7, 2. How many decimals are we bringing back, everybody? Yep, that'll end up being 2, 1, 2. 1, 2, boom. So that ends up being 2,700. Okay. Now from here, what do we do, my party people? And excuse me there, 1 second. Oh, that's right. That's my fault, guys. 1 second. Right over here, because this should have been moved over because it should have been 0.3375. Totally my fault. So right over here, this would have been over here. And so that would have been 1, 2, 3, 4 decimal places. So that should be 1, 2, 3, 4. And that shouldn't be 2,700. That should just be 27. That's totally on me. That part's on me. But let me know if we recovered from that. It was just the number of decimal places we moved and brought back. Are we good? Great. Because now that we're here, again, all this is now, everybody, can we agree that after the setup, it's just an equation. It's just an equation. Just like every math problem you'll ever do. At first it seems confusing, but that's because the hardest part is always the setup. After the setup, you're good to go. Because from here, we're going to go ahead and solve this equation. Let me lay it out for you, just rewriting it. Okay, great. So what I'll do is I'll subtract 15 from both sides. Remember, the key to solving equations is working backwards and doing the opposite operation. So the 15 positive and negative, they cancel out, leaving you with 60 equals 27 minus 15, which is 12. Appreciate you, Draco. And then now what do we do to both sides, everybody? 60x equals 12. What do we do to both sides? Divide. Exactly. Divide what? Not 12. Divide the 60. We'll divide the 60 on both sides. Right there. And that'll be x equals, and then you can go ahead and do your long division again. So allow me to do that right over here. And again, you shouldn't be fazed by a bunch of calculations because all this is really is just calculations. So it shouldn't be that daunting unless you really haven't had that much practice. In that case, keep practicing. So you should welcome the opportunity to keep showing those skills. But here, nonetheless, 60 can't go into 1, 60 can't go into 12, but 60 can go into 120. How many times? Exactly. 2 times, exactly 2 times, the 120 disappears. So we have 0.20. And as a percent, when we convert it back, that would be 1, 2, 20%. So again, after the setup, it is just procedure, it is just calculation, but it's very important that we understand the setup. So really specifically, everybody, do you understand the difference between why in this question, what we were looking for, the variable, was over here on the left side of the equation with the solution versus the other questions where, hey, when we set it up, we're looking for what's at the end, right over here. Same thing with the other one. We're looking for what's at the end, right over here. So the question is, do you see the difference between those first 2 questions and this third question that we just did? Do you see the differences? Last one was the hardest? Yeah, for sure, because the thing is, the last one was the one that you haven't seen yet. So that's fair. That's fair. My brain feels untwisted now. This is way easier now. Okay. Again, I always get a little worried, especially with the free classes, when it comes to showing these particularly tough concepts, because my goal is to welcome everybody in, especially those who are coming to their first free class. I want to welcome everybody in, but every now and then I'll take a little bit of a risk, and I'll do these crazier topics, knowing that those who stay till the end are always the ones that get the most out of it. So how are we feeling, guys? Time has flown, but how are you feeling overall about this topic, about dealing with percent mixtures? It's way easier now. I get it. Feeling good, feeling good. Now I got it. And now the task is to practice. So if you're in the program, again, this is going to be unit 13 right over here. Unit 13. This is where the advanced word problems are going to be. You're going to see an advanced distance, rate, time question in there, an advanced percent question. You're going to see an advanced fraction word problem in there, the combined work word problems. I did a class on that as well, and you should see the recording in there. But the point is, at the end of the day, make sure that you use that practice and you use the step-by-step solutions to understand how to get every single one of these questions right. So my party people, give me one moment. We still have 5 minutes. I want to show you from the back end over here. I want to show you exactly what that's going to look like. So give me one moment, because I want to show you again, excuse me, all of the power that you really hold. So let me go over here. And boom. Do you guys see my background now? All right, cool. And I'll let you screenshot in a moment. But cool. So now that you see my background, remember, for those of you in the program, all you have to do is go ahead and click arithmetic reasoning. And to see exactly what we just did today, you'll go ahead and scroll down to Unit 13, Advanced Word Problems. And if you want to just try the questions out, boom, just go ahead and click the checkpoint. Remember, it works just like every other checkpoint. You're timed, 10 questions, 20 minutes, 2 minutes a question. And when you hit ready to start, you'll see all the questions pop up in just a few moments. So for this one, once I click it, there it is. And so you have all of your questions here. So this is a combined work question, combined work. The solutions here, right here, percent mixture, percent mixture, percent mixture. And I formulate the questions every which way. I could ask you for the beginning information, the end information. And that's the beauty of it, because it forces you to actually understand what's going on instead of memorizing the question. And so watch this. Here's the best thing about this. Let's say we scroll down to the question about right over here. The 20 milliliter solution contains 90% sugar, all this stuff. What if you're sitting there and you're saying, Coach, how do I do it like you did? Well, guess what? Right over here, I show you the exact same thing that I told you today. The sugar in solution 1 plus the sugar in solution 2, that's going to be the sugar, total sugar in the mixture. And then I show you exactly how to set it up, exactly how to think about everything, how to think about the total, how to set it all up like you see right over here. And then I solve it for you exactly like I do, just right here in your face. So everybody, do you see the power that you have when it comes to continuing practicing? Do you see that power? Okay, like that's what we did with the program, man. We've been working on this for 4.5 years now, and this has been the pride and joy of this company. So I want to make sure that you guys understand how to use this to its fullest potential. And if you don't, reach out to me. You know, I'm your coach for a reason, and I'm here to help you succeed, start to finish. So with that said, let's go ahead and wrap this class up, man. How are we feeling, guys? Are we feeling like this is something that was very useful, something that was worth coming to? Boom, right there. Yeah, sounds good, guys. So one more. No, unfortunately, we don't have time for one more. But I'm really glad that you guys took the time out of your Monday evenings to spend with us and really make progress in any way that you could. So first things first, you know, for those of you that are in the program, we have another class tomorrow, 6 p.m. same time. So get on, get on into the program, keep doing your thing online, then join us for tomorrow night's class. And remember, if you haven't reached out to me in at least the last 5 days, hit me up, shoot me a text saying, Coach, hey, here's how things are going. Let me know if there's anything I can do differently. I got you. And then on top of that, for those of you, smile. Cool. And for those of you that were here for the first time or are part of our free materials, then I really would encourage you to take advantage of the ASVAB program, simply because the sale ends tonight at midnight. So for those of you who are here and again want to take advantage of that, I'm just going to skip right over to this page here. All you need to do is use the code FIREWORK at checkout, and you can save 20% on your first month subscription. Again, first month only, or you can get 20% off the entire year or 20% off the entire lifetime program. The lifetime program gives you literally everything forever. So you can come to every class forever. You'll have all my program features, all the updates, never pay a dime again. That way, if you want to pass now and then come back and get promoted later, you know that you'll never have to look anywhere else for any ASVAB content. It'll always be yours. So it's already on a discount. Now it's extra 20% off with that code. You can go ahead and use this link here, right there. Again, use Firework at checkout and you will be good. Kesey, if you want to wait a few moments, I got you. And then again, if you are trying to score as high as you can the next time you take it and you want to take your time studying, then I would recommend the year. If you're the type of person who is just trying to go ahead and pass as quickly as you can and just get over with it, then I would recommend the monthly because you would save the most off that. But if you're trying to, again, score as high as you can, you save the most with the year. If you're trying to get a passing score now and then get a promotion later, the lifetime would be the way to go. Yeah, I'm glad you get your brain exercise for the day. So go ahead and get more brain exercise by lowering that test anxiety, building up that confidence, and eventually getting that score that you want, because that's what we're here to do. So I do need to call it just a little early, everybody, today. Typically, I would take a little more time to spend with y'all and to go ahead and review any questions you have. But I'm going to go back to the last question as promised to let you take a screenshot of that. And then I am going to take any final questions very quickly before I take off for the day. So go ahead right there. If you were looking to take a picture of the previous question, there you have it. Boom, take your screenshot. And David, the place that you want to start off is going to be the program checklist. I made sure to highlight it this morning right here. Let me copy and paste it for you, David. I just sent it to you in a private message, David. So that right there is going to contain the program checklist. Go to section 3 to start learning the math. Yeah, you're welcome, guys. And again, if you are, no worries, Jack. So for those of y'all who are interested in the program, the way that the program looks, I can go ahead and show you right over here behind me in the screen. Give me one moment. So when you click the link that I sent you, this is what it's going to look like. Right here behind me, you'll see that it'll give you a 20% off July 4th discount. It'll also have the code right up there at the top. But pretty much here it is. You can go ahead and watch the video. You can watch the video right there on how it works if you'd like to. Or you can scroll down and just read the details about how to study for the ASVAB. Let me zoom on in. How to study for the ASVAB, how the program works, all the features laid out for you. I go over the same features in the video. And also the classes, how to get the recordings, everything that's included with you, your tutors, everything you could want to know about this program, all the courses you get with it, how it's going to help you and how it's all lined up for you step by step. Every bit of detail is all right there. Also showing you an example of how your progress dashboard looks. Also showing you students who have passed with us and a link to more reviews if you want to see that. And then all of the program plans, monthly, yearly, and the lifetime plan. The monthly is the only one that's a subscription, and you can cancel whenever, just like Netflix or Hulu. No risk, just cancel whenever you're done with it, and it'll end at the billing cycle. So with that said, everybody, does that make sense in terms of how to, or what the program looks like? Yeah, Grizel, absolutely. If you're watching a recording and you have a question on that recording, I would always recommend just play out that problem that you're having a question on. And then once you finish the question and it still doesn't make sense, boom, take a screenshot, send it to me, say, hey, coach, I just watched you do it. Didn't make sense. I'm stuck on this part. Boom, and I'll help you out. I respond 5 days a week, Monday through Friday. Yeah, I got you, Remy. Oh, David, it's probably because it's in all caps. Give me one moment. Let me actually lower that. All right, here you go, David. Right here, David. So this should be it for you, David. There you go. And Grizel, so it was formerly $397. It is now on discount for $297. And then with that 20% discount, you get an additional discount. Yeah. So it's a crazy deal. You should probably take advantage of that because I know at the end of summer, the prices will be going up because we are adding in 3 more great features. But, oh yeah, and just to make it clear, if you pay now, you don't get the price raised on you. The moment that you're done paying, the upgrades and updates are included for free. Oh, Landa, I appreciate you putting that in there. Yeah, and if you want to get an overview of a student who uses the program exactly how it's supposed to be used, start to finish, I would definitely read Landa's review. Landa's been a student of mine for quite some time, and I've appreciated every bit of progress she's made. And she's definitely someone who has the credibility to talk about my program. And Landa, if you wouldn't mind, I'm going to copy and paste what you said into YouTube as well. If that's cool with you. Boom. Thank you, Landa. I appreciate you there. Yeah, so let me go ahead and bring it back over here so you can see the screen again. So again, you can use the code FIREWORK, all caps, and hit redeem, and you can save 20% off the monthly plan your first month. Again, your second month and beyond will be billed regularly at 60. You can get it at 48 bucks a month with that code for the first month, or you can go from 297 down to, I believe it's going to be something like 212, I believe, or 237, excuse me. And then the lifetime goes down by quite a bit because it'll go down from just about 500 down to, I believe it's going to be less than 400. So great deals all the way around. And again, they end tonight. Yeah, right on, Santiago. And we're continuing to improve. So whatever you guys recommend today is not going to be the same as next month because we're always getting better. Yeah, that's right, Kesey. Yep, exactly. There's a class today, tomorrow, Wednesday. Next week, same thing, Monday, Tuesday, Wednesday. And you can see when all the classes are right over here with the schedule. Boom. Great. So with that said, guys, I am going to go ahead and step away for the evening. Yeah, you're welcome. I'm always happy to answer your questions. So again, I do need to step away for the evening just to get some rest, just because you guys are aware of, some of you guys are aware of my medical condition. So I'm going to go ahead and step away for the evening, get some rest. But you guys are absolutely welcome. I love having you guys. Here are the details again. There's a link with the coupon code, so feel free to save that before I close the room. Same thing with everybody on YouTube. There's the full program there with the code FIREWORK. That way you can save 20% off your first month or your year or lifetime packages. And with that said, I will see you guys in tomorrow's class. Let's keep raising that score and raising the acing the ASVAB. And remember to keep getting one day better, one day at a time. That's all you can do. So that's all we should do. All right, guys. You guys have been amazing. You guys have a good one. And yes, Jay, the year is a one-time payment. You're only billed once.